Imagine spilling hot coffee on yourself in the morning. Engineers have designed coatings that can repel water and other liquids, but a critical question remained. Would these same coatings perform well when the liquid is hot? In most cases, the answer is no. I'm Dan Preston, Assistant Professor of Mechanical Engineering at Rice University, and in this work, our group set out to understand why that happens and how to fix it. Traditionally, people have tried to solve this problem by making highly complex surface textures or exotic chemical coatings. But what we show in this work is a different idea altogether. Instead of changing the surface texture and chemistry, we redesign the thermal behavior of the surface. So by adding a thin insulating layer beneath the standard superhydrophobic coating, what we do is prevent heat transfer that would otherwise cause condensation and loss of water repellency. This shift in our approach opens the door to scalable, low-cost, and durable hot liquid repellent surfaces.
I'm Rawan Rashid. I was a PhD student in the Preston Lab and a co-lead author on this paper, and I'm now the CEO of Helix Earth, a Houston-based startup working on dehumidification technology. In the Preston Lab, we combine carefully controlled experiments like sliding hot water droplets and impinging hot jets with analytical thermal models. The key idea is that hot water creates vapor that can condense inside surface textures and make the surface sticky. By adding insulation, we slow that heat flow enough to suppress condensation so droplets keep bouncing and sliding off. What was especially exciting was that this approach worked on large areas, curved surfaces, and even with real liquids like hot coffee, milk, and soup, not just idealized droplets of water in the lab. That combination of experiments and modeling really shaped how I think about engineering problems today.
The bigger picture here is that thermal design approach that we've used in this work is just as powerful as either chemistry or microfabrication in controlling the surface behavior. And for Rwand, this project was a great example of how fundamental research can translate into real-world technologies, something that he's doing now at Helix Earth with a growing team here in Houston.
For me, this project and my PhD training at Rice at the Preston Lab showed how deep physics-based understanding can turn into practical, scalable solutions, and that's the mindset I now bring to my role as CEO.